Hi, Giri. Yeah, hi, Giri. Uh, Hi, Giri. Thanks for joining the call today. So let's discuss about how to deploy a microservice architecture, application built on with microservice architecture in cloud. Okay, so the idea is to discuss for TopTraits.ai, if you build the whole application on microservice architecture using Java and Angular, like how much does it cost and what are the considerations that we need to look into with regards to deploying it in AWS cloud, so or any cloud for that matter. So let's get started and let's discuss what are the considerations that you would look into as a cloud architect.
Yeah, hi Sai. Thank you for inviting me into this podcast to discuss about your application deployment process. And uh, thank you for choosing me in this platform. So first of all, before we are going to choose our platform, first we need to understand what is our business case. So from how many users are concurrently going to access our application, and at the same time what is the type of a database we are going to use, and where our application is going to be accessed by our users, and also at the same time how many microservices we are going to use in this application. So first of all, we need to understand the basics of how we are going to prepare our applications. So I would like to request you to uh, let know where actually we are going to host our application. So whether it is a North America, South America, Asia region. So based on that, we can choose the platform which is going to give us the low price, best performance from the cloud side perspective.
Yeah, so it's mostly USA, not even North America. So we'll just focus on USA for now.
So in drop trades AI application, how many microservices we are going to have in the background? Hopefully we all know that most of the microservice architecture consists of at least two microservices. One is the front end, one is the back end, and another one we are going to keep as a database instance. So I would like to know how many microservices we are going to plan to use in this application selection.
I think to begin with, probably we'll have 4 to 6 microservices.
We are planning to, okay, let's assume we are having a five microservices. So one is a managed database, and four microservices in the behind the scenes. So these four microservices, one is a front end, three is the back end services. I hope I remember that you said this application is building upon the Java, right?
The Java backend Spring Boot microservice and front end would be Angular. That's correct.
Okay, so how many number of users are going to access this application? So basically, the first system design or system design principle starts from where how many users our application is going to access. So what is the starting point of our user count we are expecting to access this application?
So the user count is, to get started, I think we'll have any given day 1,000 concurrent users. The traffic probably would be, any concurrent users probably would be around 100 in a given day, but visitors would be 1,000
So we can start with 100 users as a
concurrent users.
concurrent users on a day, on a single day.
Yeah, we're getting started. So yeah.
So when we say users, so we also need to first understand what are the parameters we are going to take from the users when the user is signing up for our application. So basically, it depends on that. We can choose our database size as well when we are first creating our managed database. So suppose example, we are going to take a first name, last name, email ID, date of birth, and their mobile number to send some notifications, etc., etc., right?
Yeah.
So can we expect that one user account metadata or data would be around less than 1 MB?
Yeah, it will be pretty less. I mean, what I just stated, like email ID, phone number, first name, last name, should be good enough. And we don't, yeah, and at the max date of birth and the city that they are living in. So nothing more than that. It's
Okay.
pretty, pretty slim that way.
Yeah, probably less than 1 MB per
Yeah,
user, right?
definitely.
So might be I would expect a database we need at least 10 GB as a starting as an initial database is a first when we are trying to, because this is for the 1,000 users graph when we are talking a 10 GB of database, so that at least from this a 5 GB would be already used, and 5 GB will be remained, and we can select the database that can be expand automatically when the users are increasing signing up for our application.
Yeah, I
So
think 10 GB, we probably can go with 1 GB if that's an option, because I don't anticipate a lot of data to be put in SQL database. Most of it will be screenshots and things of that nature from the trade setups, the trade setup, like how the chart is performing. Those kind of things will be put probably in the storage. So it will be more images.
One thing we need to understand when we are choosing our managed database instances in the cloud is there is a criteria that we need to choose a minimum database. So that is a 10 GB as a minimum database in AWS, and GCP it would be 20 GB as a minimum database, and I hope Azure as well it is somewhat around a 10 GB. That is a minimum database we need to select when we are creating any managed database instances. So we cannot go less than that. We have to choose that one. And after that we need to understand that what are the components we are going to put in our entire application. So sometimes we need to store images, as you said, screenshots and all, right? So for this we need to use a blob storage instead of the database for these kind of images, or any kind of a small kind of a clips, or any ads we want to send to users when we are using. So at this time we need to use a blob kind of a storage, something what S3 we can use. And the next one is, okay, the application is going to be hosted only on the North America region, right? So, and as we know that this application has only 4 microservices in the background, so not more than that. So here we have plenty of options. When we go to the cloud providers, we can go from AWS to Azure, GCP as well. So in all of these, we need to understand which cloud provider is going to provide us the best and a low uh, cost, but at the same time their services should be available for us on the 99% as a uptime. So if we choose AWS, we have a plenty of options to run the microservices architecture. One is a ECS clusters, and another one is EKS, so which is a Kubernetes. But here we need to understand, we want to go with the little complex, or we want to go with the very easy way of deploying our application. So that the standpoint of view when we are deploying an application is we need to understand how much we are going to invest on the capex and opex as well. So opex in the sense, when coming to not just by developing the applications, also we need to pay to the cloud engineers when we are choosing a technology. So if it is a Kubernetes, it is a little complex technology. So for that, we need to at least hire 2 engineers who can able to perform and manage the Kubernetes clusters, and at the same time the platform also. So when coming to Kubernetes, again, I'm trying to explain that the components involving when trying to deploy the application on the Kubernetes cluster. So it is not just by only one component. We have to maintain multiple components, and at the same time we need to choose our virtual machines running in the background, because that virtual machines are responsible for running our microservices containers inside the virtual machines. So suppose, basically example, when we create a Kubernetes cluster, the Kubernetes cluster itself is not a one virtual machine. Okay, the Kubernetes cluster.
You can type in and talk. That's all.
Yeah. So when we try to deploy an application on K8s cluster, it is not just by one or two virtual machines.
What are the two options that you said? Like EKS and EKS and Kubernetes, right? Like we totally, how many options we have to deploy the infrastructure?
Yeah, in AWS, we have a ECS and EKS. These are the two options available. And in ECS also, we have two ways of deployment options are available. One is a Fargate, and we have another one is EC2 deployment method. But these two are directly managed by Amazon itself. So there will be no, not much skill requirement from our side, even though the developers themselves also able to manage this at least 50% of level once the infrastructure is created and deployed. But in case of if it is a EKS, if it is an EKS, there should be definitely a dedicated Kubernetes engineer and platform engineer, both are required. So let's say an example, a Kubernetes engineer also know the AWS platform. He can work on creating the resources using Terraform. He can also able to create the CI/CD pipelines, plenty of all the tasks from the DevOps to DevSecOps to platform engineering, he can take over. Okay, there is no doubt. But in case of if we choose ECS, it is way better and less manageable and easy to access thing. So why? Because ECS Fargate is totally a serverless and managed by the AWS itself in the background. So when we choose Fargate, after creating the ECS clusters in the ECS option, the Fargate, whenever we deploy any services, okay, it will create a multiple services and multiple tasks. So I would say around 1,000+ tasks it can handle. It can scale up to 1,000+ tasks in the background. Okay, whereas EC2 also same, but when coming to the EC2 part, we need to choose what type of machine we want to deploy in the background. So suppose example, it is a T2 micro, T3 micro, or small micros or large VMs. It depends on our container image or type of a workload we are putting inside that EC2 instance. But most probably, our application nowhere required to go beyond 4 CPU and 8 GB RAM. We can go with the Fargate. Okay, and also if our microservices
What is
are
it? Can you type in the requirements? Like what can Fargate handle?
uh, I believe Fargate can handle up to uh,
You can check in Java.
Fargate can, let me
Yeah, let's check and check.
So Fargate can go up to 16 vCPUs in the custom configuration and 32 GB RAM. So pretty much our workloads can able to run on the Fargate itself. So it is way better and less managed headache in the background. So developers can just check their pipelines. If the pipeline is successful, they can directly go ahead into the application URL, try to access, and whatever the new features they have added, it is deployed or not, they can easily understand by going through this Fargate method. But in case if we go to EKS for the the less microservices application requirement, we need to first deploy the EKS cluster. Okay, the control plane, whatever I call the control plane. Okay, the first thing is control plane. We need to deploy the control plane, and after the control plane we need to deploy the worker nodes. Okay, a single control plane itself is required a 4 vCPU processor and 8 GB of RAM as a minimum requirement when we are deploying a control plane, so that the performance can be at least matchable to our worker nodes. So at least we need to deploy two worker nodes. We cannot go with the single worker node with the ECS cluster. So total we need at least 3 VMs in EKS. Okay, so we need to again understand these VMs are always running in the background. Okay, so 740 or 750 hours in a 30 days of month cycle, these VMs are running continuously. Okay, these VMs are not scaling down automatically when there is no request. Okay, even if the containers inside the worker nodes are might be going down, okay, going down to zero, but the VMs itself is not going down. The VMs itself are running in the AWS account. So it is generating bill for us. Okay, so if our application is not required to run 24 by 7, okay, in the cloud, then we no need to go ahead and take the EKS. And at the same time, if our microservices are not more than 9 or 10, then we no need to create the EKS clusters. We can directly manage our application on the Fargate itself, or even if we want, we can choose the GCP as well. GCP has a more user friendly UI compared to AWS, but yeah, the Azure still trying to catch up. The user interface is not that great because it's a multi-layer options comes over on top of another option in the Azure. So if you click one option, it will come up another layer on top of it, and you need to find another options. If you close one layer, and you will go back to the previous layer only. But in GCP, it is a clean and clear UI compared to even AWS. AWS is also good, but somewhat it lags behind compared to the GCP. And GCP is a straightforward. Okay, whatever you want, you just need to enable that APIs. You will be only going to charge for those APIs running in the background. AWS is something not like that, but at the same time, AWS has a flexibility over here. It is not just 16 CPUs. It is also goes beyond 1,000 plus tasks can be created in the background when we choose the Fargate. But in GCP, it can go up to 496 only. So when coming to the load, horizontal scaling specter or vertical scaling standpoint of view, AWS is a best choice when choosing. But again, it comes to the cost perspective also. Somewhat around, if our applications are running something I can say like around 700 minutes or 700 somewhat requests per month, I would say somewhat around GCP cost would go 100 to $200 per month. But
what is the traffic that you're stating? Like, how many requests you're seeing?
I'm saying something around, let me get you some. Okay, so in GCP, the Cloud Run is pay per use, right? Here I'm talking about Cloud Run only in GCP, because in GCP the only option is Cloud Run. There is no instances, VM instances level option in the GCP, such as AWS has. AWS has a multiple options in the ECS clusters, okay, where you can choose the serverless, and also you can choose the VM based instances. But in GCP, it is only just a Cloud Run, which is a directly cloud serverless and managed by the GCP. And the cold starts, when the trigger comes, and GCP Cloud Runs can start less than 5 seconds. Less than 5 seconds. Okay, but in terms of ECS Fargate, it takes around 15 plus seconds to start the call. The trigger can start. It has a little bit of delay when starting it, but Cloud Run, starts very fast compared to that. It is a practical, tested, at least on my side. Whenever I try to deploy any application, the Cloud Run starts very fast compared to the Fargate. And the Cloud Run charges are pay per request, and it is also based on the how much CPU and how much memory we are going to use. So suppose example, it is just a 24 cents a million request. So if we go to the ECS Fargate,
So 24 cents per, so 24 cents per million requests.
Yeah, a million request. And a million requests, that is not just by one or two, a million request. Okay, so pay per task. So when going to the ECS Fargate, you will be priced per task. So how many tasks are running in the background will be charged for those number of tasks, and how much CPU you are utilizing for that task, and per hour. It is also based on the per hour only, but here it is based on the million requesters. So if you don't have any requesters, okay, for your application, you will not be charged. So that's how actually the GCP price will be very less compared to the AWS one. But in terms of scaling, the AWS can scale up to 1,000 plus tasks in the background, but GCP can go up to somewhat around 400, less than 500, 400, 450 to 500 only. So this is the another point we need to make sure. And also the database instances, and at the same time, we also need to note about the load balancers. Okay, after this, we need to talk about load balancers, because our application needs to be hosted on the internet. So users are need to access our applications through a portal. Okay, so an URL, we will create an URL, so users will be accessed our application based on the URL itself, right? So to host our application, to make our application accessible for users, we need to create the load balancers, because load balancers are distributes the traffic be behind multiple microservices, right? So, and also here we need to note down what kind of a load balancers we want to use. So most probably a web application always uses a HTTP or HTTPS load balancer, where we can terminate the traffic over there and send our requesters to the microservices. So load balancers charges are depends on the how many hours our traffic is coming to our services. So suppose example, the HTTPS load balancer charges for the forwarding rule is something what around 0.02 pi for hour plus forwarding rule costs, where we can able to check this costs in the cost table section of the GCP or AWS cost calculator as well. But yeah, we need to use the network also. And at the same time, we also need to remember all the egress traffic, which we are going to use in the cloud are chargeable in VPC standpoint. So ingress is free, egress is always chargeable. So how much GB of data you are ingesting to third party, that is a chargeable. Okay, and after that, we need to choose.
So one question. So when would you choose EKS versus Fargate? If I'm going with AWS, so when what would be a scenario where I have to use EKS, or I prefer to use EKS versus Fargate?
Okay, so Ah, when we need to use EKS or when we need to choose ECS. So it's a completely depends on the application and the application, workloads and number of microservices we are going to run over here. So if the number of microservices are increasing, then managing through the Fargate and other cloud run or container apps in the Azure, it is little bit of messy and clumsy. So at that time, we will choose our EKS clusters when where we can able to utilize the namespaces here, so that we can differentiate different types of background services or foreground services or other kind of microservices running inside the single cluster. And also, if our application is continuously need to be up and running. Okay, so there should not be any even 0.001% of downtime and also. Okay, and also another point is that the performance. Okay, I'm not saying that the Fargate or the Cloud Run doesn't give the same kind of a performance. It will give, but again, it depends on the our application. The workload, how much workload it is going to do. So suppose example, if our one of the microservices is required at least more than 18 vCPUs, okay, more than 64 GB of RAM, then yeah, we don't have any option to choose the Fargate or Cloud Run, because both are not providing us that much level of computing power. when we are trying to deploy on the managed, container-based services. So at that time, we have to choose either virtual machine and deploy our application, or we need to choose EKS or GKS and we need to deploy our application inside that instances. So, to the instance, we are going to provide more computing power, and inside that, the pod will be created as a container and it is going to execute the task, whatever the required tasks hits it. So, the difference is very simple. How much, work is our microservice is going to do, our service is going to do, our container is going to handle. So it basically depends on that. Suppose example, again, one more example, not thousand, not 100 concurrent users. We have a 50,000 concurrent users on a single time. So the first phase, the load balancer will try to send the traffic behind each individual container. And also, if the containers are receiving more than 10,000 users, okay, at a single point of time, then definitely the application is going to crash, can't handle the traffic, right? Because yeah. Yes, exactly. So the Fargate tasks will crash in the background because it can't handle that much of traffic. The CPU or the memory can't able to, those many requests from the at a single standpoint of time. So then these containers going to crash, and when the containers are crashing, the the ECS managed service automatically try to create number of services again in the background. Okay, it is not going to sit idle. The managed service will try to create a number of given services, number of given time, how many services tasks we required. The service will try to make sure those many tasks are running in the background. But at the same time, if every service, whenever there is a hit coming and it is crashing, then there is no point of using the ECS Fargate, right? So that time we can leverage EC2, but again, the microservices are very huge. Our application has a more than 20 plus microservices in the background. Okay, payment, checkout, okay, user details, account details, okay, coupon details, something like that. Okay, or else different kind of modules are there, something like electronics, okay, and clothing section, okay, kitchen section. Okay, these are the different microservices are there. More than 25 plus microservices are there. So in that case also, we cannot go with the AWS managed or GCP managed container services. We have to go with the EKS or GKS. At that time, we need to leverage the what we call this performance or the options available from the Kubernetes. Okay, so then we can leverage this, at this type of use cases. And we need to remember one more thing. It's not just one-time deployment of our application. It is a continuous improvement, continuous testing, continuous deployment. Okay, so if for small application we choose EKS, the developers are going to face a lot of challenges because the deployment phase in the Kubernetes is not simple. Okay, we need to use something called like Argo CD, okay, or Tecton pipelines, okay. So these kind of another third parties we need to use to deploy the applications into our clusters, not just only GitHub Actions. So in GitHub, developers can store their source code, but how the source code is going to deploy when there is a push is happening, there is a commit is happening, okay, there is a PR request is raising. Okay, so it has to go through the build process and it has to go through the deployment process. When coming to the Fargate or Cloud Runs, it is a very simple. The construction of the CI/CD pipelines are very simple. Okay, you can write in a single CI/CD action file, GitHub action file. You can write the build, you can write the container securities, you can write the source code quality checks. Okay, every kind of a gates and vulnerability scans you can place in a one single GitHub action file, and also you can run the multiple jobs. But when coming to the EKS, you need to use another tools such as Argo CD or Tecton pipelines. We need to go out of our plate and we need to get a third-party applications integrated into the services. So that is another complexity we are putting on head of the developers. If it is a small startup company, they are only focused with the developers and trying to give their best with their application. Then they are going to invest some more amount for to hire for platform engineers or DevOps engineers or DevSecOps engineers.
Makes sense. So I think for startup like top trades, we probably would go with either Fargate ECS Fargate or Google Cloud Run, right? So that probably would be the conclusion of the application, the server, at least the server point. I think we are going to go with those two to begin with. Correct?
Yes, even compared to AWS, I can say GCP would be very best because it is a more straightforward than the AWS. Okay, I'm not saying that AWS is that much complex, but it is a little bit higher in terms of the pricing point, and a little bit of the drive is required when you get into the console. But in GCP, no. GCP, the way they they have seen the other two cloud providers, right, before they are coming into the market. They have seen the AWS, they have seen the Azure as well, Microsoft Azure. So they created their UI, their console, what actually lacking in the Azure and AWS. So their organization structure, they have created like org on top, on below to the org, the folders, on below to the folders, you can create multiple projects. Okay, so in each project, no service will be by default provided to, by default, no service will be enabled. Okay, no API will be enabled by default in the background. So we need to go ahead and we need to enable each API, and we know that what kind of a services we want, and we are just enabling those services. We are only working on those services. So where you can able to, you know you don't need to go wrong with any other services creating by mistakenly.
No.
Okay, because the service will not create automatically. It will first pop up the API page, then it will ask you the request to enable the API.
Okay.
When you enable, then only it will start giving you access to create those services.
Makes sense.
And you can restrict that for by creating different roles or different custom permissions for different users. So any user cannot go ahead and create that. So this is another plus point from the GCP side.
Okay,
And
what
also,
about the database? Like in the GCP, like let's say if you go with GCP, what are the options for the SQL database?
so we have a MySQL, we have in GCP.
Right.
Okay, at least in GCP, they have a MySQL, they have a Postgres, and
So if you go with Postgres, is there a minimum amount that we have to pay, or can we scale it from zero, cold start kind of thing, or do we have to always have something running?
no, it's not like something running, but it's something like you have to take at least 20 GB of storage. That is a minimum requirement to create any managed database instance.
Yeah, as you were saying earlier.
Compared to our own, database, the 20 GB is very less. Suppose example, if you want to go with the Postgres Enterprise version, Enterprise Plus database, this is, I remember last time when I'm checking their price for 20 GB. If we run our database for 750 hours, or continuously running, even though, okay, that would cost around $54 per month. 50, less than 50 only, as I believe. Yeah, always we can, whenever there are changes happens, always we can go to the GCP cost calculator and we can enter what type of a license we want to use for the database, how much storage. And yes, there is an option available. That option can be expandable. you know uh, when your data is increasing, automatically the database will expand. You don't need to put that number, such as okay, right now I want 20 GB, after 4 months I'm predicting like 40 GB I need. No, you don't need to enter like that. You can just create your database with the 20 GB, and whenever the 20 GB it hits, at least 19 GB it is hitting your database, automatically the database will progress, it increase systematically, automatically it will increase the database size. And one thing we need to remember from the other cloud providers, once the database is increased, it cannot reduce. Once it increases, it increases. That's it. It cannot reduce back. So this is another point we need to remember. And when coming to not just only the services, we also need to make sure what kind of tools we are going to use for the security purpose and container security, because you know everybody thinks that once we create the container and deploy it, it is done with our pod. Not like that. Okay, every container base images, we call it as a root fs images. So every time whatever the type of a base image you're pulling, that vendor is updating their root fs images. So we need to make sure our containers are scanned every time whenever there is a pipeline running. Every time before we are deploying, we need to make sure our containers are vulnerability free, and at the same time we need to make sure our containers are patched. We shouldn't leave our containers, because the containers are a new type of virtual machines. In earlier older times, we talk about virtual machines, right? So we created virtual machine, we are patching the virtual machine, okay, we are updating the virtual machines. But right now it is equivalent containers as well. So we need to patch the containers, we need to update the containers. We shouldn't provide the root access inside the container. Okay, we have to disable the root access inside the container when we are deploying the application. So these are the security measures we have to make sure. And at the same time, we need to make sure the container health checks as well. So most widely used by our Grafana and Prometheus tools for the monitoring purpose. Yeah, we can choose these open source tools, or otherwise we have a third party tools like such as Datadog or any other kind of tools also. But probably as a startup, if we have a ability or capability to deploy our own monitoring tools, I would suggest going with the Grafana with a Prometheus. Very good option. It has a very good responsive time, less than 200 milliseconds. It captures every time the changes are happening in the background. Okay, it captures our metrics and it will put onto the Grafana very beautiful dashboards. We can customize the dashboards at the same time. The metrics can be called by the Prometheus in the background. So these are the options available for us, where we can able to leverage the open source what is available as a startup, instead of going through different kind of a third party softwares, and finding an engineer who is more experienced on those third party softwares, rather than choosing a basic open source application at the beginning of time, and when can focus on the application improvement, application performance optimization. This we can able to leverage.
Sounds good. Okay, Gary, sounds good. I think that's a very good discussion. Let's try to wrap up and then continue more in the series format. Okay.
Sure, definitely. It's nice talking to you,
Yeah.
Sai.